I found this tremendous diploma question. You got to see this. Read it. Go. A Math 30-1 class was asked to determine the general solution for the following equation in degrees. Now, remember, you're dealing with degrees, not radians anymore. Okay? So, answers were provided by 4 different students, all shown below. Student 1, student 2, student 3, student 4, blah. But now read this part. This is the part that I thought was very, very interesting. It says the 2 students who provided the correct general solution. So in other words, it's not just one person, it's 2. Aha. So what do I do in a situation like that? Well, you know what? I wouldn't even look at the solutions. The first things I would do is I would take this equation here and I would solve it. Same way you've always solved equations, okay? So let's check this out. Watch this. First thing I'm going to do is I'm going to notice that I've got cosine here and here. Okay, so I'm going to take the cosine out. Factor out the cosine, leaving me with 2 sine theta minus 1. Oops, forgot the theta there. There we go. Minus 1 equals to 0. And then just straight out solve this, just like you would normally solve. Okay, so I got cos theta, then equals to 0. And then the 2 sine theta minus 1 equals to 0. Solve this guy. Well, the cos theta is easy because if you think about it, the cos theta, the only places that cos theta could possibly be 0 is here, of course, which is 0, comma 1, and down here, which of course is going to be 0, comma negative 1. So we know the degrees for that. That's going to be 90 degrees. That's going to be 270 degrees. Yippee skippy. Okay, we got that one. So let's figure out this other one over here. All right, so when you're doing this one, remember, add the 1 to both sides. There it is. Oops, there we go. That cancels this guy out, giving you 2 sine theta equals to positive 1, divide by 2, and then sine theta equals to 1/2. Beautiful. So find me where sine theta equals to 1/2. Now, you know this because look, dun, 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 sine theta, of course, is going to be 1/2 at 30 degrees. And the other one where it's going to be 1/2 is going to be way over here at 150 degrees. Okay, now I'm going to show you something really cool about this. All right, so if we wanted to figure out the general solution, we can do them separately. And you're probably saying, well, of course I would do this separately. Yeah, but you're going to miss something if you do everything just separately. Watch this. If you did this one here, check this out. Wouldn't this be 90 degrees and then multiply, or I should say, add 180 degrees and you would get that one? Add 180 degrees, you would get that one. See how that one works? So the general formula for this would be 90 degrees, right? Plus n times 180 degrees, and n is an element of I, right? Because all you're doing is you're adding multiples of 180 degrees. Makes sense, right? 180 degrees takes you from here to here, from here to here, from here to here, from here to here. You're always adding 180 degrees. So let's go back to our formulas now, to our answers, and see if we can find one that says starting at 90 degrees, just keep adding 180s. Okay, so let's go back to here. So look at this. Well, this one says starting at 60 degrees. Well, I know student 1 is way off right off the bat because look at both the answers. Both the answers, 30, 150, 90, 270. So I don't know where this student 1 got his ideas from, but gone. Okay, now look at this one. This one says student 2 starts at 90, but it's adding 360. So if you think about adding 360, think about this. Look, you're starting here and you're adding 360 means that you're missing the guy down here. So no, I wouldn't go with student 2 either for now. For now, okay? For now, because there's something special about student 2 I want to show you. See how easily we can get distracted. I'm going to show you something really, really amazing right away that's going to freak you out. Look at student number 3. It says n times 180. Well, no, because what does n times 180 mean? 180 means starting here, and n times 180 means you're just going to get to this point over and over again. So I'm going to go no on the student 3 for sure. But I'm still wondering about this guy first. This one's bothering me. Okay, well, anyways, let's go back to student number 4. Look at this. Student number 4 says take 90 degrees, and look at that. adding multiples of 180, which is exactly what we want to do here, starting at 90 degrees, adding 180, adding 180. Yes, that's looking good so far for student number 4. Okay. And then this one says 30 degrees plus 360 of n. Okay, so there's 30 degrees. Well, yeah, adding 360 will get you back to the same spot every single time. Okay, so I can handle that one. That checks out. And then 150 adding 360 degrees. Okay, so I'm going to start over here at 150 adding 360 degrees. Yes, that sounds okay. So I'm going to level with student 4. I'm going to say student 4, yes, you're good. Okay, so student 4 is going to be my proper answer. But this says 2 students. So somebody's wrong. Remember this one here? This one kind of bothered me. And one of the reasons why it bothered me is because if you think about it, and let me just erase this here. If you think about it for a second, okay? Think about it for a second. This guy actually kind of worked, didn't it? That says I'm starting at 90 degrees here, but I'm adding 360 to it every single time. So that checks out this point. But what about this point? Remember how I was talking about this point? You're not going to see it unless you draw it all on one axis. Here we go. Hold on a second. Let me clean this up and we'll get to it. I'll show you. Do you remember this guy when we said we're at 30 degrees out here and at 150 out here? Do you remember this? Okay, watch what happens. The other two are at 90 degrees here, right? And at 270 degrees here, right? Now, we took care of this guy, if you remember correctly, a couple seconds ago by going 90 plus 360 plus 360. That's this guy, where you took 90 degrees, you add 360, add 360, we checked out this. But we couldn't figure out how we're going to do this. Watch. This is going to freak you out. You ready for this? It's hilariously incredible. Watch. To go from 30 degrees to 150 degrees is how far? Oh, that's 120 degrees. Oh, that's interesting. To go from 150 degrees to 270 degrees is how far? Oh, that's 150. Oh, hey, I just took care of the 270. No, this isn't going to work, is it? Watch this. If I had 120 degrees to 270, I get 390 degrees, which is, guess what? If this is 360, guess what? There's my 30 degrees. So all I have to do is say at 30 degrees, keep adding multiples of 120. Oh my goodness, look at that, eh? So look, I started at 30 degrees and I'm adding, oh, this one here. I'm starting at 30 degrees and I'm adding multiples of 120. So the two proper answers are student 2 and student 4. Isn't that just a delightful question? It's such an incredible question. You got to look at it again. Watch this one again. This is just, it freaked me out the first time I saw this question. Enjoy.